Good morning, children. So in the last class we had studied about the separation of mixtures. First we had studied about evaporation, how the dye from the dye solution, that is water is a solvent. So how dye can be removed from water by the method of evaporation. Then we had also studied about the separation by centrifugation, where butter can be removed from curd or the cream can be removed from milk by centrifugation when the mixture is rotated at high speed. And then we also had studied about the various principles which is involved in evaporation, centrifugation, etc. Today let's discuss about the method to separate two mixtures, one of which is sublimable and other one is not sublimable. So now let's understand first what is sublimable material substances or non-sublimable substances. You must have already studied this term in the first chapter, sublimation. So sublimation is a process by which solids on heating directly converts into the gaseous or vapor state. So on heating, it will not change into the liquid state, it directly converts into the gaseous state. This method is known as sublimation. So there are certain solids which are sublimable and they are volatile in nature. Volatile means they have very low boiling point or melting point and they directly just little bit heat only it will get converted to vaporized. Non-volatile means it has high melting point or high boiling point. So which are the examples of sublimable material? Sublimable material, one element you must have already learned, that is iodine. Is a sublimable substance. It directly, it's a solid, so when it is exposed to air, it just converts into the gaseous state. Another sublimable substance is camphor. You must have seen it is used in prayers and all, people burn this in temples and all, and then that is a camphor which is used for that. This is also a sublimable material. Another one compound which is common example is nothing but ammonium chloride. Ammonium chloride is also a sublimable material. So these are the examples of sublimable substances: iodine, camphor, ammonium chloride. There are certain organic compounds also which are sublimable. Like you must have seen mothball to keep away the moths, pests and all in the house, so that naphthalene balls are used. So naphthalene is nothing but it's an organic compound, it is sublimable. Then another compound is known as anthracene. Anthracene is also a sublimable organic compound. And another common thing which you can see is in your washroom, bathrooms and all, you must have seen in a box it is kept odorant, that is room purifier. So odorant and all are also sublimable. You can see that when you buy it, it will be having a very good size. But slowly by slowly, as you keep it, you can see the volume, the size decreases. That means it is directly vaporizing. It is getting converted to from solid state to vapor state. So the examples of sublimable substances are iodine, camphor, ammonium chloride, anthracene, naphthalene and also odorant-like substances which are there. So they all are sublimable. Now which are non-sublimable material? Non-sublimable are common salt, sodium chloride. Sodium chloride, NaCl. So it is non-sublimable. So it will take high, that is it is non-volatile. It has high melting point. It will not directly convert into the gaseous state. Another example of non-sublimable substance are copper sulfate, potassium dichromate, potassium permanganate, all that comes under non-sublimable material. Sodium carbonate, sodium sulfate, sodium sulfide, all are the different kind of salts which you have learned. Copper sulfate is also a non-sublimable substance. Now, sublimation, the main principle in sublimation is when there is a mixture of sodium chloride, suppose salt, you have sodium chloride, NaCl and camphor. Mixture of sodium chloride and camphor, if it has got mixture, how to separate it? One is non-sublimable substance, other one is sublimable substance. One is non-volatile, other one is volatile. It has high boiling point, it has low melting point, this has low melting point. Another example, suppose a mixture of sodium chloride NaCl and ammonium chloride NH4Cl. Even ammonium chloride is a sublimable material. So if this kind of mixtures, the salts have got mixed up, it has become impure, so there is some impurity in it. So how can you remove the impurity from these mixtures? So we use the method for separating this kind of sublimable material from non-sublimable. It is known as sublimation. Now here the principle is there, when you take this mixture of salt and camphor or salt and ammonium chloride and you have to keep it in a apparatus, this is known as China dish. China dish, it can withstand high temperature, so you are using China dish over here. Otherwise beaker and all, it will not withstand the high temperature. Keep it on a tripod stand and then you have to take a funnel which is used for filtration. So funnel made up of glass, so you can see it very clearly. Take the funnel, take a mixture inside the China dish, take the funnel, keep it inverted over it. So otherwise what happens, you can, this camphor, it will just vaporize out, you cannot collect it. So why you are keeping the funnel is so that you can also collect the camphor. That is one of the substance you can collect it. So take a funnel, keep it inverted. So for the substance not to vaporize out, the lower end of the funnel should be, you have to plug it with a cotton plug so that the vapors will not escape. So this is the whole experimental setup. You have to take a tripod stand, this is the wire cord, so you have to take a China dish, take a funnel, keep it inverted to collect one of the salt which is getting sublimated and then you have to keep a cotton plug for the vapors not to escape. Now, heat the mixture, take the mixture in the China dish, heat it using a Bunsen burner or a spirit lamp. And then, you should not heat it, another precaution which you have to take is don't heat it at a very high temperature, heat it slowly. Otherwise, by the time you heat the experiment, you will not get time for observing it. What is observation? So heat it slowly and observe carefully. So when you see it, when you heat it slowly, you can observe, that is after some time, vapors of white color vapors rising up from the China dish. When you are heating it, vapors of one of the substance rises up. And then you go on continue it for 10 to 15 minutes and then allow it to cool. When you cool this, you can see there will be some white color substances sticking onto the side of the funnel. This white color vapors, that is when you cool it, first it will start vaporizing and then switch off the burner and then you can see there will be a white color substances which sticks onto the inner side of the funnel, and this is known as sublimate. And then after some time, remove the funnel and you can take a glass rod and scrape out the white color substance. So what do you see? Which compound it will be? What do you observe? So the observation is, you can see by this method, in this camphor we have taken the mixture of salt and camphor. Camphor is sublimable and salt is non-sublimable. Camphor is volatile, it just gets converted very quickly, having low melting point. Salt is non-volatile, having high melting point. So you can see here, when you heat it, the camphor just directly from this mixture, it changes into vapor state and rises up. And then after cooling it, the vapors condense on the inner side of the funnel and it will be collected. So, and what will be left behind in the China dish? Salt, sodium chloride will be left behind in a China dish. So this method is very, very useful for separating the mixtures like salt and camphor, salt and ammonium chloride. So any sublimable material from non-sublimable material, you can separate it by this method. So you have to draw the diagram, label the parts. The main reason why cotton plug is kept here, so that the vapors of the sublimable material, that is camphor or ammonium chloride or iodine, should not escape. So here you will find here this is a sublimate of camphor. If you are using camphor in it, camphor will be collected on the inner side of the funnel, and in the China dish the salt will be left behind. So this is a method, it's known as sublimation. This is useful for separating the sublimable material from non-sublimable material. Hope you have understood this well. And the other example is sodium chloride and camphor, sodium chloride and ammonium chloride, or sodium chloride and iodine. Normally iodine it is it's an element, solid in state, it is also highly sublimable. So these are the example of some sublimable substances and non-sublimable substances. So children, we had studied about sublimation. Now let's study another method of separation of mixtures, that is known as chromatography. So what will you do when you have to separate the different colors of a substance? So you know that when you paint or draw, you know that you can get a pink color by mixing red color and white color, or you know the brown color is made up of some other colors like black or green and all is mixed. So you must have seen this in your day-to-day life. Suppose there is an ink drop which has fell onto the newspaper, which acts like a filter paper and all, blotting paper. And if some little water falls on it, you can see how the colors spread on the newspaper. So that is a simple technique which we are going to use over here. That is, in a dye, how to find out which are the different colors present in a dye or an ink, black ink or brown ink or sketch pen colors, you know that blue color, how it is made. Okay, what are the colors of pigments in a dye? So if black ink is used or brown ink or any other ink, how can we separate the different components of that mixture? So the ink or the dye and all are nothing but mixture where different colors are mixed together. Like you know that orange color, you can get orange color by mixing the yellow color and red color, or green color and red color. If you mix it, you will get brown color. So you must have seen all those when you do the painting and all. Similarly, if there are certain pigments, okay, like flowers and all, different flowers are there around you. There is orange color flower or chlorophyll in a plant and the leaves and all. So how to know which are the different pigments present in that natural substance? So for that separation of mixtures of different colors from a dye, we can use this method known as chromatography. Chromatography, chroma is nothing but it's a Greek word. Chroma means color. So it's nothing but chromatography is a technique where the different colors in a component can be separated by this technique. So what is the method in that? The simple method in that you have to take a filter paper. There is a chromatographic paper also which is available for doing this work. There are certain numbers given there, 15, 16 and all, it is present in the lab. So you have to take the chromatographic paper or simple filter paper, or you can do it in your house by taking that is a strip of newspaper, and then you can carry out this experiment. You can see it in your house itself. So what you have to do, take a filter paper, cut it into a rectangular piece, and on the lower end of that, just about a little bit like around 1 centimeter or 2 centimeter, draw a line. After drawing a line, you put a drop of ink, whichever ink color you want to see, which are the different colors present in the dye. So that water soluble paints you can take it, because we are taking water as a main solvent here. So water paints you can take it from your paint box, any one color, brown color or pink color or violet color. You can take that. Violet also, red and blue color, when it is mixed you get violet color. So put a drop of ink in the middle. Just leave a little space from bottom and put a drop of ink on this varying amount cross, and then leave it for drying for some time. Once the ink spot or the color dries, you take it and put it in a glass if you are doing it in your house, the experiment, or we have this is known as a gas jar. So in the gas jar, this is a glass rod, and put the filter paper fix it onto the glass rod by using a paper clip. This is a paper clip over here, this is a glass rod, and this is a filter paper. And the filter paper, here this is the spot where you have put the ink. Now it is dry. It will be dye or any spot of ink. This is a gas jar, and then in the lower end of the gas jar, fill with little water. And then you can see that the filter paper, the lower end of the filter paper should just touch the water. The ink spot should not be touching the water. The water level should be just, the ink spot level should be just above the water level. So be careful, that is a main precaution over here, and then leave it for some time. After some time, when you keep it for some 1 hour or something, what you can see the colors slowly, it will be spreading onto that is, it will spread onto the filter paper and form different layers. Different colors will separate it out from this dye. So the mixture, whichever color we have used for making this ink, that colors will get separated. So that is the principle of chromatography. Now what is the principle of separation? How the mixtures, the colors are getting separated? The color which is more soluble in water, please observe, understand this properly, more soluble, the color which is more soluble will move very faster, and that will be connected, it will be forming one layer on top, and which is less soluble in water will be moving very slowly, and that color will be left behind at the lower end of the filter paper. So this is how you can get a variety of colors. Suppose if you are taking green color, you can see the yellow color, and then you can see the green color moving up. Or if you are taking the violet color, you can see little bit the blue color form, and then you can see the red color form. At the same time, you can see the variety of colors, and from this you leave it for some time, and then you can, by looking at the colors, you can also make out which color is more soluble in water and which color is less soluble in water. So which is more soluble will move faster and will form the upper layer. So you can see a very nice layers of water, that is the color will be formed over here. And one more important thing when you are using this is the paint should be, or if you are taking water, all the paints or the ink should be water soluble. It should be having a common solvent. So if you are taking some other solvent, like if it is an organic compound, some oil paint and all, in that time water cannot be used. So for that alcohol is used. So little bit of ethanol is used and little bit of distilled water is put into that, and then that will be used as a solvent. So water, it is a solvent and it will dissolve the dye which is present here, and it moves along with the dye, and the different range of colors will be formed on the filter paper. So this is the main principle of chromatography, where you can separate the different colors of a dye. So it's an easy method. Now where we are using this? This can be used if you want to get any pigments from the natural color. What are the different colors present in the natural, from the flowers or from the leaves, that can be used for this. And it is also used for separating the different colors in a dye. And also very important, one more application is there. It can be used to find out what are the different components of the blood. Blood also, it is used for, blood also can be tested, and what are the different colors and all, it can be used by carrying out this method. So this is also another method of separation of mixtures. Dye is a mixture of different colors. So in one particular dye there will be different colors. So that can be, this method can be very easily used for carrying out this separation of mixtures. And all of you can try out this in your house. It's very simple experiment. You can take a pencil. On the pencil you can take a newspaper or any filter paper which is blotting, like not a very fine butter paper, little bit filter paper like newspaper strip, you can take it, and on the lower end you just put one drop of ink and then place it in a glass of water with the help of a thread and tie it on top, and then you can observe it. Then you can see very nicely the variety of colors will spread onto the filter paper. So this method is known as chromatography, where we are using for separating the different colors present in a dye. Hope you have understood this much. Now let's learn the next method of separation of mixtures, that is distillation. Yes children, so we have studied two methods of separation. First we have studied about the sublimation, hope you have understood that well. Then chromatography, where the colors of a dye can be separated. So in the first class, that is the previous class, you have also studied how to separate two immiscible liquids. Do you remember that? We had used a separating funnel, that is to separate water and kerosene oil, or water and oil can be separated because it forms heterogeneous mixture. That is, water and kerosene, they don't mix together. So what kind of liquids are they called? They are called immiscible liquids. So immiscible liquids can be separated by using a separating funnel, where we had poured the water and kerosene into the separating funnel, and you saw that the water had settled down, kerosene has settled on, was present on top of the funnel, and very easily by using the opening the cork, that is, the water can be drained out and remaining kerosene will be left behind in the separating funnel. Today we will see how to separate if two components of a liquid, they are miscible, they mix together, you cannot separate it. Like suppose mixture of water and acetone. mixture of water and acetone. Okay, so when acetone in here, what happens? This is an organic compound where when we put water into it, it is soluble in it. So here what is the main principle is, we are going to separate the miscible liquids. Miscible liquids. Miscible means which two liquids they combine, they don't form two different layers. The acetone is soluble in water and will form a single layer. They are known as miscible liquid, which form two distinct layers, with the mixtures of two liquids which do not mix together. It is known as immiscible liquid. So miscible liquids can be separated by this method. For example, water and acetone forms a miscible liquid. Another example is water and alcohol. Water and alcohol is also another example of miscible liquid. So here, what is the main principle they are using is, water and we have to take the liquids which are miscible, and also their boiling point should be, there should be a lot of difference between the boiling point of two miscible liquid. Then we can use this method known as distillation. So here, the water has, what is the boiling point of water? 100 degrees Celsius. Whereas the boiling point of acetone is less, it is 56 degrees Celsius. Boiling point of acetone is 56 degrees Celsius and that of water is 100 degrees Celsius. So two liquids which are miscible have a lot of difference in their boiling point. They should have a lot of difference in their boiling point, should be large. Then this method can be used. So for that, this is the experimental setup. So I hope you can see it properly. This is a stand, clamp is there, and this whole apparatus is known as distillation flask. Distillation flask, and in the distillation flask, mixture of water and acetone is taken, or mixture of water and alcohol also can be taken in this. Now this distillation, this apparatus, on the side there is an opening, and here what happened? Here is the place where one of the liquid is going to change into vapor, and then it is going to condense over here and it is collected in the beaker below. Now here in this part of the apparatus, the water vapors pass through the inner tube. This inner tube is surrounded by a water condenser. It is known as Liebig's condenser. And what is the main purpose of this is, when you heat the mixture of water and acetone, one of the substance will turn into vapor, vaporization, and then this vapors have to be cooled. So for cooling the vapors, water condenser is used. So water condenser has two opening over here. This is inlet. This end, what happened? Cold water is allowed to enter to cool the water vapor. So this is the cold water inlet, and this cold water will be cooling the vapors which is passing through this inner tube. And once the hot vapor passes through it, cold water will cool the vapor, and this water will become hot. So hot water will be removed from this upper end. This is the outlet for that. This is the water outlet. That is, the water will become warm and it can be removed. So main purpose of this condenser is to cool the water vapor. So that is any vapor which is passing through this inner tube. So this is the experimental setup. This whole apparatus is known as distillation flask, which has a side tube through which one of the vapors will be passing through that. And at the same time, this is a round bottom or the distillation flask. One more precaution what we have to take is, we have to keep the thermometer. Thermometer is used to measure, that is the boiling point of the vapor which is being formed. So we have to, as I told you earlier, for any cooling, for any heating purpose and all, the heating should be done very, very slowly. So what is the step over here? So in the distillation flask, mixture of water and acetone is taken, which are miscible liquid, having quite a lot of difference in the boiling point. Water boils at 100 degrees, acetone boils at 56 degrees Celsius. So this mixture should be cooled, should be heated very slowly, and then you have to carefully read the temperature. So when the temperature nears around the 50 degree and all, so observe carefully what are the changes, what is taking place in the distillation flask. So when the temperature reaches around 55 or 56 degrees Celsius, you can see the vapors of one of the liquid formed over here. And this vapor, you go on heating it slowly, this vapor will rise and it will pass through this inner tube. This vapors, it will pass through the inner tube. So can you tell me if it is 56-degree vapor of which substance will be coming out first? Is it vapors of water vapor or the vapors of acetone? The acetone has lower boiling point, water has higher boiling point. So when 56 degrees Celsius, around that it is reached, the vapors, the acetone, which is a liquid state, it will turn into the vapor and the vapors will start rising up and will pass through this inner tube. And since the vapors are very hot, it's warm, so that has to be cooled by using water condenser. So this lower end water, cold water will be let inside this condenser. So it will cool the vapors which is passing through this inner tube. So the vapors will be, that is when the liquid changes into vapor, what is that process known as? Evaporation or vaporization. And then what happened? This vapors will pass through here. This vapor, cold water will cool the vapor. So vapor will turn back into water. Well, vapors of acetone will turn back into water. So into the liquid state. So that process is known as condensation. So there is evaporation over here. The vapors of acetone will be turning into liquid acetone and then it will flow down and liquid acetone is collected in the beaker below. This is in liquid state. This is vapors of acetone which will be in the gaseous state. That will be cooled by using the water condenser and the water will become warm and this outlet for the hot water to move out. The warm water can be moved out, will move out from this outlet and cold water is for this. So the vapors of acetone will cool, it will condense and then it will turn into liquid acetone and liquid acetone is collected in the beaker below. So this method is known as distillation. So distillation is a process where there are two processes we are studying about. First one is what? Change of the liquid acetone into vapor. So liquid into vapor, on heating it is known as vaporization. And in this there is a second process where the vapors of acetone is turning into liquid acetone. So this is known as condensation. So distillation will be involving both evaporation and condensation and then the acetone will be collected over here. And then what will be remaining behind? Water will be remaining behind in the distillation flask. And this one more important thing when you are carrying out this experiment, you have to keep the temperature constant for few minutes time. You have to go on observing the temperature and then you can see slowly the whole vapors of acetone will be collected in this beaker below. So this is an important experiment, please understand it. Acetone will be collected over here and water will remain behind in the distillation flask and then thermometer is kept to read the temperature of the whole mixture. So it should be below that is the temperature of the lower liquid which is having lower boiling point, that is acetone. So the whole mixture should be heated very slowly. So as the temperature reaches to 55 or 56 degrees Celsius, then the temperature remain constant for some time and then heating also should be done very slowly. So you can see the vapors of acetone will be formed here, whereas the water which has higher boiling point of 100 degree will remain behind in the distillation flask. So this is an important experiment used for separating two miscible liquid and which have very large difference in the boiling point. And acetone, you know that it's an organic compound. Where it is used, it is mainly, you can see it in the nail polish. This is the solvent used in nail polish and all. So you can see as you apply, you can see it will vaporize out due to the body temperature. So hope you have understood all the three methods of separation of mixtures. I want you to look into the slides, understand the concept very well, draw each diagram neatly, label the diagram and then you have to write the notes, mainly aim, method, observation and conclusion, and very important, principle of separation of those kind of mixtures. So thank you children. So children, now look onto the slides. So we have studied sublimation, chromatography and distillation. Now see the slides and understand the concept. What is sublimation? You have learnt it in the first chapter, so try to recall it. Sublimation is nothing but it is a change of state directly from the solid state to gaseous state without changing into liquid state. And there are many sublimable substances known. So the examples are iodine, ammonium chloride, camphor, naphthalene is nothing but mothballs, anthracene, then dry ice, toilet freshener like Odonil are all sublimable substances. Now dry ice, you can see the picture over here. Dry ice is nothing but it is solid carbon dioxide. And carbon dioxide in the solid state, it directly, when it is taken out, it sublimes, it starts subliming, it changes into vapor state. That is at what temperature? Minus 78.5 degrees Celsius. That is frozen solid carbon dioxide changes into the vapor state. So that is dry ice, and this is a picture to indicate the dry ice. Now, what are the examples of non-sublimable substances? So, the examples of non-sublimable substances are sodium chloride, copper sulfate, sodium carbonate, calcium carbonate, etc. are non-sublimable substances. Now, you can look into this diagram and understand the process of sublimation well. Suppose if you have to separate a mixture of salt and camphor, you can separate it by sublimation. And here, this is a china dish, and in this you have to place a mixture of salt and camphor. And then keep an inverted funnel over the china dish. And this is the stem of the funnel. You have to keep a cotton plug over the stem of the funnel so that whichever is a sublimable substance should not escape through the funnel. So after that, heat the mixture slowly. So when you start heating it, you can see that the dense white fumes of camphor starts rising up inside the inverted funnel. And then once the vapor rises up and the vapor stops forming, you have to cool it, switch off the burner, and then observe it carefully. Keep it for some time. Then on cooling, you can observe that is camphor, which is sublimable. It will be condensed on the side of the funnel, and the sodium chloride will be left behind in the china dish or the evaporating dish. So here that is a mixture of salt and camphor. One is sublimable substance, that is camphor, and other one is non-sublimable. So this kind of mixtures can be easily separated by the method known as sublimation. Now you can see this diagram here. Here also this is another example. Here we are taking in the china dish, that is salt and ammonium chloride. Ammonium chloride is also a sublimable substance. So take this mixture of ammonium chloride and salt in an evaporating dish or china dish and keep an inverted funnel over it, and precautionary measure is you must keep a cotton plug at the stem of the funnel so that whichever the vapors of the sublimable substance should not escape through the funnel. Then start heating the mixture slowly, and then you can see that dense white fumes of ammonium chloride vapors are formed, which rises up, and continue heating it slowly till the vapors stop forming, and then allow the apparatus to cool down. Then on cooling, you can observe that is the particles of ammonium chloride will be settling on the side of the funnel, and the sodium chloride, which is the other mixture, non-sublimable, will be left behind in the china dish. So this is how you can separate a mixture of sublimable substance from a non-sublimable substances. Now, what is the aim of sublimation, right? That is, so what will be the aim? What you're going to write? To separate a mixture of salt and camphor. What is the method you're using to separate it? Sublimation. This can be salt and ammonium chloride or salt and iodine, any example. So if one is non-sublimable and other substance is sublimable, the method used to separate them is sublimation. Now on heating the mixture, a sublimable volatile component from a non-sublimable component, the sublimable component camphor vaporizes and non-sublimable component salt remains behind in the china dish. That is the principle behind sublimation. Then what is the procedure? As I told you, procedure means how you are going to do the experiment. So take the mixture of salt and camphor in a china dish, cover the dish with an inverted funnel, close the stem of the funnel with a cotton plug so that the vapor, why you have to do that? To prevent the vapors of camphor from escaping. Now heat the mixture slowly and observe. Now you have seen the experiment. Now let's answer a few questions. So what do you observe when a mixture of salt and camphor is heated? So observation is dense white fumes of camphor, sublimable component are formed which settles down on the sides of the funnel. And the second observation is sodium chloride or salt, which is non-sublimable, remains behind in the china dish. So you have to write both the observation, learn it properly. Next is give examples of mixtures which can be separated by sublimation. So which can be separated: salt and ammonium chloride, mixture of salt and iodine, and mixture of camphor and salt. All these substances can be separated by using this simple technique known as sublimation. Let's see the next part, that is chromatography. Chromatography is nothing but chroma means color. Okay, it's a Greek word, so chroma means color. This method was first used to separate different colors in a dye. That is why this name came up as chromatography. And this what we are studying is known as paper chromatography technique, where we are using paper, that is filter paper. There is special filter paper which we use only for chromatography. So here, and what we are going to do is you have to take the filter paper, a strip of filter paper, and just above the filter paper on the lower end, around 2 to 3 centimeter, you have to leave it, draw a line and mark a cross there. And on that cross, you have to just put a drop of ink, which color you want to see. It may be orange color or green color or brown or blue or violet, anything. And let the ink dry for some time. Then you have to, after the ink dries, you have to take the filter paper, put it into a beaker or glass, and then you have to fix the filter paper by paper clips onto a glass rod or a pencil, whichever you're using it. And then leave the mixture leave this apparatus like this for some time. After some time, you can see you have to pour little water in the beaker or the glass, whichever you're using it. It should not touch the dye. It should be just below the ink spot or the dye which you have put. It should be just below the level of the water. It should be just above the level of the water. It should not be dipped into the water. And then observe carefully. So when you observe it, what you can see is, that is, the dye which is present, which we have used, is water soluble. It has different colors in it. So as you keep it through the pores of the filter paper, the water rises up the filter paper. So as the water rises up, what happens? It takes the colors also along with it. And you can see a layer of different color will be formed onto the filter paper. It's a very nice experiment to be done. You all can try out in your house. And here, the main principle is different colors are soluble in water, but the color which is more soluble in water will travel faster and to reach on the top, and the color which is less soluble in water will be at the lower level. So from here, what you can tell, which color is more soluble? Yellow. Yellow is more soluble in water, so it has reached on top. Whereas the purple color, which is over here, is less soluble in water, so it remains on the lower end. So you can see a range of color is formed on the filter paper. So violet color, then blue, and then little orangish, then pinkish, and then you can see the yellow color. So this method is known as chromatography. The colored pigments of a dye can be separated by this method. That is, water is the medium over here and all the colors are soluble in water. This method is used for that. This experiment you can also try out in your house by taking a blotting, that is newspaper. You can take it, newspaper where there is no color and all. You can take a strip, put a little bit of ink in it from your sketch pen, orange color, brown color or green color, and then fix the filter paper carefully onto a glass. Okay, tie to a pencil and then fill little water in the glass and then observe it. You can get this color, very different layers of colors onto the filter paper or the newspaper which you have seen. Please try this experiment at home. So now what is chromatography? What we have learned, this technique. Okay, that is, it is the technique for separation. Chromatography is nothing but the technique for separation of mixtures or solute which dissolves in the same medium by passing it in solution. Solution, what we are taking is the water in which the components move at different rates. So that is the meaning is, the solute which is more soluble will travel faster than the solute which is less soluble in water. So this is the colors, you can see it. As I told you, you can try out in your house. So take a paper, filter paper. If you're not having it, you can take a newspaper and then you can place different spots of color. Like you can keep it here, the red color, or then green, and then different orange, brown color, or the purple color, or the blue color, and then dip it in the water and then observe it. So you can see here the water is already absorbed. It is absorbed by the filter paper here, and it's traveling. So as the water travels onto the filter paper, it carries the different colors along with it, and you can easily see which are the colors present in the dye. So you can see it is here orange color, means red color. It is having here red and yellow, and the next one was green. It has a bit of yellow color in it, and which is on top, the color layer of color which is formed on top is more soluble in water, and which is formed below is less soluble in water. This is another experiment of the same, that is chromatography, where the different colors of a mixture can be separated by this simple technique. And since we are using the paper here, it is known as paper chromatography. So what are your observations? So as the water rises in the filter paper, it takes along with it the components of the dye particle, which is a mixture of two or more colors. So that is the main principle of chromatography. State the reason for the rise in the colored spot on the filter paper. Why the color spot rises in the water? So the components of a dye are soluble in water. The colored component that is more soluble in water rises faster than the component that is less soluble in water. Thus, components of a mixture get separated by this simple technique known as chromatography. Now, what are the applications where we can use chromatography? We can use chromatography to separate colors in a dye, the pigments from natural color, to separate various drugs from the blood. In the blood, if any other drug is there, we can easily separate it. We can also separate different pigments from the extract of flower. You know, flowers, there are beautiful colors there. Orange color is there, pink, green, yellow. So what you can do is, you can use this method. You can take the flowers, crush it, and then you can put a spot on the filter paper and carry out the same experiment. You can see which are the different colors present in a flower. And this technique can also be used in the food materials. If you have bought some chili powder or turmeric powder, or some food which you bought it from outside, packed food like chicken and all that, you know that red color will be added to that. Okay, so you can take little bit, take a spot from any other food material and put it on the paper, and then carry out this experiment. You can easily see which all are the colors which are present in that, which colors have been added into the food material. Next method which we had learned was distillation. So this is the entire thing is known as the distillation apparatus. This is a stand on which it will support the distillation flask. Distillation flask, it has a round bottom flask over here, and here there is a condenser. The tube over here, it is surrounded by Liebig's condenser. And here in Liebig's condenser, what happened? The cold water enters from one end and the warm water will be removed from the other end. Now in this distillation process, there are two physical changes which is taking place. First is evaporation, that is whatever content which you are taking it evaporates, and the second physical process which will be condensation. The vapor rises up, it moves through the inside thin tube, and to cool the vapors, the water condenser is used. So cold water will cool the vapor and the vapor will condense back. It will be condensed back into the liquid state. So here, this distillation, we are learning that how to separate a mixture of acetone and water. And this method can be used in two liquids which are miscible, which will mix together, not like kerosene and water. Acetone and water are liquids which will mix properly. They are miscible liquid. And first point is they are miscible liquid. Second, they have difference in their boiling point. The boiling point of water is 100 degrees Celsius, whereas the boiling point of acetone is 56 degrees Celsius. So they have lot of difference in the boiling point. So if the liquids are miscible and if they have lot of difference in the boiling point, we can use the method to separate such mixtures by distillation. So take the mixture of acetone and water in a distillation flask. And you know that acetone has lower boiling point. So in order to check the temperature, very important, you have to place a thermometer inside the distillation flask. And then this is to read the temperature, and you have to set the apparatus in this way, and keep a beaker over here or receiver flask. It is known as receiver flask, where we are going to receive one of the content of the component of the mixture. Now take the mixture of acetone and water in the distillation flask, fix the thermometer and start burning the mixture slowly. So when you start heating the mixture slowly, after some time you can see that vapors of one of the component rising up, and then observe the temperature. So you can see the temperature goes on rising, and at about 56 degrees Celsius you can see more vapors being evolved, and you know the approximate boiling point of this acetone is 56 degrees Celsius. So as you go on heating it, the vapors of acetone rises up first because it is having lower boiling point than water, and then it passes on to this thin tube through the condenser. The cold water which is running around running in this condenser cools the vapor of acetone, and acetone, it will change back into liquid state and to be collected in the receiver flask or the beaker. So here acetone is in liquid state, it is changing into gaseous state, and then it is again on cooling, it is again changing back into the liquid state. And what about water? Water will be left behind in the distillation flask. So this is the main principle of distillation. So what is distillation? It is a process involving conversion of liquid state, that is vapor, by evaporation, that is subsequently condensed back to liquid form. Distillation process can be used to separate two or more miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Now, from the experiment, what you can observe? What is the boiling point of water? The boiling point of water is 100 degrees Celsius. What is the boiling point of acetone? 56 degrees Celsius. So there is lot of difference between their boiling points. So we can use this method for separating it, that is distillation. Then, why do the two components separate? The two components separate due to the difference in their boiling point, and at what temperature the thermometer reading becomes constant, that is at 56 degrees Celsius, that is the boiling point of acetone, the thermometer reading becomes constant. Now what is the observation after the experiment? On heating the mixture, the vapors of acetone rises first due to the lower boiling point, and then it condenses in the condenser and gets collected in the receiver flask. Pure water having higher boiling point remains behind in the distillation flask. So, where all you can use this method of distillation? We can separate a mixture of ethanol and water, mixture of acetone and water, and we can obtain pure water from salt solution by distillation, and also we can separate a mixture of kerosene and petrol by this method, where all these are miscible liquid and have lot of difference in their boiling points. So I hope you all have understood these three methods. So please write the notes neatly in your notebook, draw all the diagrams neatly and label the parts. You have to read the textbook well, learn the notes well, and learn all the keywords well, important words which you have learned like chromatography, sublimation, distillation, volatile, non-volatile. Learn all that and understand it well, and pertaining to this, all the exercise questions are there in your textbook at the back, so you can do that. And so please be prepared for the test. Learn well. Thank you, children.